right, so from the Unit 6 A and B review sheet, we're going to do 3 problems on the 6A side, number 3, number 4, and then ultimately number 8. So if you want to just check those out, just some thinking behind these problems. So number 3, we know that a lot of people want to distribute that 2, however, that exponent is stopping that from happening. So we need to address that exponent first, which means we need to square x plus 4. At this point, I've turned this into a complete multiplication problem, and we know in multiplication, order doesn't really matter. So you will see some students want to distribute the 2 into that first section. That's great. We get 2x plus 8. Now that still needs to be multiplied by x plus 4. Other students might keep the 2 there and then go ahead and double distribute all of the x plus 4 times x plus 4. So if they get x squared plus 8x plus 16, and then distribute the 2 into there. Either way here, we should end up with 2x squared plus 16x plus 32. If we do it that first way, 2x times x is 2x squared, 2x times 4 is 8x. We get another 8x in the middle, and then 8 times 4 plus 32. 8x is combined to 16x, and we get our 2x squared plus 16x plus 32. So either way you do that, it works. Just a reminder that you cannot square just the x and just the 4. That's not how exponents work, and you can't distribute that 2 before addressing that squared. All right, reason we chose number 4 is a lot of students want to turn this into a multiplication problem, but if you look at number 4, this is a subtraction problem. So we got some simplifying to do with 4 times the quantity of 2x minus 1, some simplifying to do over here, probably including that negative, but then it's just an adding and subtracting, combining like terms type of problem. So if we look at this one especially, we're going to distribute that 4. We get 8x minus 4. Now take that negative 6x, that entire guy there, and distribute that in. That gives us negative 6x squared positive 30x. Notice there's no more parentheses. There's no more multiplication. So at this point, we're combining like terms and rearranging. Get negative 6x squared in the front. Then we've got a positive 8x here, and then a positive 30x here. Add those together for 38x, finally with a minus 4 at the very end. That's in standard form. And again, taking a subtraction problem and leaving it as subtraction, not trying to do too much and turn it into multiplication. You'll see some students want to start distributing across here. Cannot do that. This is just a subtraction problem. Last one we want to look at, because all these other ones are pretty similar to ones that we addressed. So let's look at number 8. In this case, we've got 3 different quantities multiplied by each other. Again, since multiplication order doesn't matter, you can choose to address the first 2 if you want and multiply those first, or you can choose to address the second 2 if you want and multiply those. All right. Either way, it doesn't matter too much, so I'm going to distribute that 3x and that 2, and I'm going to leave that x minus 2 off to the side still. We're going to address that multiplication in a little bit. Now notice this is all connected with multiplication, so whatever I get, I will have to multiply by x minus 2. If we go ahead and do that multiplication, we get 3x squared minus 15x and plus 2x gives me a negative 13x in the middle and a negative 10. Now I do need to do 6 more multiplications, right? 3x squared needs to get multiplied by x and negative 2. Same thing with the negative 13x. Same thing with the negative 10. So we're looking at 3x cubed minus 6x squared. Negative 13x times x is negative 13x squared. Negative 13x times negative 2, positive 26x. Negative 10 times x, negative 10x. Negative 10 times negative 2, positive 20. Now we just got to take a couple of our like terms and combine them here to get our final answer, 3x cubed minus 19x squared plus 16x plus 20. All right, you might have to see a problem like that on that test, so it's helpful to prepare in how we do that multiplication, making sure that we don't over multiply or turn it into an addition or subtraction problem when in reality it is all multiplication.